Hello and welcome back to 18.3. Today we'll be translating trigonometric graphs. We'll be starting with explain 1. So on here you'll see in the directions they want us to identify the period in the midline of the graph, as well as for sine and cosine functions. So there's going to be a difference between tangent and sine and cosine. So if it's a sine or cosine function, they want us to identify the amplitude and maximum or minimum values. If it were a tangent, they want us to identify the isotopes and the values of the half points. And then, of course, to graph at least one cycle. Alright, so since it's a sine and cosine function, as you can see here for letter A, I'm going to use this format. So it says f of x equals our A value, which is 3. Now, I know a lot of students are like, well, where is my 1 over b value? I don't see it here. Well, here, when there's no coefficient, like for example, if I said there's an x here, what's the coefficient of x? You would say 1, right? So what if I said, what is the coefficient of x minus pi? It'd be the same thing, right? So we'll put a 1 there. Try and make that 1 visible. Alright, so that would be our 1 over b value. Our h value would be pi, and our k value would be 1. Okay, so first thing we're going to do, we're going to do step 1, 2, 3, and 4. Some of them are just, once we have identified our values, they're just plugging in. In fact, like for step 4, what's the amplitude? Well, since a is 3, amplitude is 3, that means it goes as high as 3 and as low as negative 3. Our midline is going to be our k value, which is at 1. So when I draw this out, my midline that it kind of goes up and back around, it's not going to be perfect, but it's going to be at about 1. And then, last but not least, our b value. So since our b value is actually, it's 1 over b, I should say, 1 over b equals 1, we're going to solve for b. So 1 over b equals 1. Okay, so let's go ahead and write this as a fraction, and let's cross multiply. What's 1 times 1? 1, right? And 1 times b? Just b. So that means our b value is actually 1. Cool. Step 2 is to find the period, which is 2 pi times our b value, which was 1. So what would that be? 2 pi. Cool. Awesome. So we've identified our period. Yay. We've identified our midline. I'm really about these happy faces, by the way. And we also found our amplitude, which they did ask for, so cool. Amplitude is found. Awesome. So they do want a maximum and minimum value. So we need to do that. We need to know where they occur. As you can see from the picture, we kind of know where that is. It's going to be as high as 3 and as low as negative 3, but let's also graph the function so we can have some specifics. Alright, so for here, since it is a sine function, our starting point of our parent function is going to be 0, 0 for a sine function. But since it translated our h value and our k value, so I'm going to look back at this, h value was about pi, it's a positive pi, and our k value is a positive 1. That means that our graph's actually going to start, since it is a positive number, do you think we're going to go to the left or to the right? To the right. And since 1 is a positive number, do you think we're going to go up or down? Up, right? To, of course, pi 1. Alright. We kind of already know where our midline is, so I'm not going to have us do this. We're actually going to draw our picture out for this graph, which is going to help us to kind of find our minimum and maximum values, which is what they want to know. So let's go ahead and use our Desmos.com. We're going to use the graphing calculator. And let's go ahead and type this in and get some values for our graph so we can write this here, make a sketch, and answer the rest of the questions. Alright, so welcome back for the graphing portion of our Explain 1 Part A. So we're going to go ahead and go to Desmos.com, just as you see here. We're going to press Start Graphing. And what we're going to do is, once it loads, we're going to type in this equation, f of x. Instead of f of x, I am going to write y equals. And I'm going to write in 3. Now, as you can see, I don't have sine on here, so I'm going to pull up my keyboard. Functions, sine, somewhere here, I promise. There it is. X, take away pi, close the parentheses, plus 1. Notice that every time you move the graph, it does kind of get rid of those points. So just in case you didn't know, that's what happens. Alright, so take some time and go ahead and graph this out, and we'll go ahead and answer the questions on the page in just a moment. So as we could see here, we graph negative 3 pi over 2, negative 2. We also graph negative pi over 2, comma 4, 0, 1, pi over 2, negative 2. So it keeps bouncing back between 4 and negative 2. Just notice that in a little bit. We're going to almost finish this up. 3 pi over 2, comma 4. And it's a sketch, so if it's not perfect, it's okay. 5 pi over 2, negative 2. So I'm going to kind of draw a curve as best I can. Again, it's not important that it's perfect. It's just important that it's there, right? It's not as easy as sketching a line, right? Like a straight line. Okay, so our maximum value, it looks like, it goes as high as 4. But remember, A value is 3, so it's going to go 3 units above the midline. Alright, so remember our first value is pi over 2. So I'm going to write that in, pi over, or pi 1, right? Pi 1. And here, so that should be pi 1. So that way my graph's a little bit better. Alright. Oh, pi 1. Where'd you go? Where did you go? There you are. Don't scare me like that. Alright, and then it says between the first and second point. So, as you can see here, our maximum value here is about 3 pi over 2, comma 4. Our minimum value, as you can see here, is our, so it's going to go, again, 3 units below the midline. By the way, if you're wondering, what was that midline anyways, Mrs. A? Remember, our midline was about 1. Midline was y equals 1. As I'm kind of drawing that out a little bit. That's why it keeps going 1 plus 3 is 4. 1 take away 3 is negative 2. And that's going to be at 5 pi over 2, comma negative 2. So we have our values for our max point and for our minimum point. And you'll notice that that kind of just keeps repeating over and over again. Now a lot of students probably do ask, like, can't I just graph this and answer all the questions? Do I have to use this worksheet to identify everything? It's just nice to know these patterns, you know, so that way you're just answering most of the questions in the beginning, and then you're just using the rest of your graph to kind of answer the rest. All right, let's go on to explain 1 part B. So here you're given a couple of sentence starters, so that's a little nice. Let's identify again our A value, our 1 over B value. Oh, that's a fraction and it's actually visible to us. That's kind of nice. Our H value, which is 2 pi, and our K value, which is positive 2. So here, let's start with the period. So that's what they want us to know. So first thing we're going to do is we're going to identify what is 1 over B. Well, that's equivalent to 1 over 2. So let me go ahead and solve for B really fast. 1 over B equals 1 over 2. Let's go ahead and cross multiply, and that would be B. 1 times B is just B. And 1 times 2 is 2. So our B value is 2. And that means our period's going to be that 2 that they already wrote for us. How nice of them. But remember, our period's found by multiplying 2 pi times 2. So that would be, what's 2 times 2? 4 pi. So they're already helping us find our period, which we have to do. The next thing we're going to do is find our midline. So they say midline is y equals k. Our k value was 2. That one, and then and where the line crosses. So here we're also going to find for a sine or cosine function. So since it's not a sine function or cosine, we're going to skip to the third sentence. Tangent, we're going to identify the isotopes and the value of the halfway points. So it says the point 0, 0 on the graph y equals tan x. So if it was just tan x, this is where it would start. Instead, our h value here is 2 pi. As you can see there, h is equal to 2 pi. Since it's a positive, do you think we're going to go to the left or to the right? To the right. And our k value is a positive 2. So do you think we're going to go up or down? Well, up, right? Because it's positive. All right. So that means our actual starting point is going to be 2 pi, comma, 2. And just so you know that, yes, we could graph it and find the isotopes, but the isotopes, remember, are those lines that our graph kind of doesn't cross. So this is just my sketch. I know they're visible. I just said they were invisible, but they're pretty much lines that the graph is kind of contained in. And it's isotopes half a cycle to the left and to the right, or at x equals 2 pi minus, and you're wondering what goes here and then what goes there, because it's going to be kind of the same thing. Well, since they said it's half a cycle and our whole period, as we found, 2 pi minus something, and it's going to be the same thing, whatever we put here and here, so that way we can find our isotopes. So since we found our starting point to be 2 pi, just like we see here, our starting point is 2 pi, that means what's half of the h value? What's half of 2 pi? What's half of 2? 1, right? And it's still a pi, just so you know. So for this, what's 2 pi take away 1 pi? Pi. What's 2 pi plus 1 pi? 3. Now we could finish the rest of these sentence starters here that they give us to fill out. So on here, they're asking us to find the halfway points. We could do that by taking the value here of our pi and 3 pi, our pi and 3 pi, and just using this formula here. We can also, yes, it's a lot easier than it was on the last one, to just graph it out and see this, but let's go ahead and fill in our sentence starter, and then we'll graph. We'll just verify if this information is true. And you could choose either way. You can use all of these different formulas and stuff to kind of predict some of these values, or you can just graph it out and kind of just tell me what you found. One's probably simpler than the other. But anyways, pi plus 2 pi is 3 pi, and 3 pi plus 2 pi is 5 pi. And then it says the halfway points between points of y equals tan x have y values of -1 and +1. Because the a value is, and I kind of forgot, what is our a value? Our a value is -2. And this, oh, and it's right there. Huh? Look at that. It would have been right there. The halfway points are reflected across the midline and stretched vertically by a factor of 2. So that means that, so they kind of give us the values right here, what to use here. So here we're going to write in -1 for one of these and a +1. They did the nice thing and kind of put in our a value for us and our k value. Our a value and our k value. We just have to work this out. Alright, so what is -2 times -2? +2, right? And what would 2 plus 2 be? 4. On here, what's -2 times 1? -2. Plus 2 would be 0. Alright, so like I said, we can use these to find our points before we actually graph our function, or we can use kind of Desmos.com graphing calculator to kind of graph that out. So I'm going to do that right now. So let's go ahead and type this in. Instead of writing f of x, I'm going to write y equals -2. And instead of using the function key, I could also type in the word tan, and it gives us tan anyways. Right, divided by, so it only divides the 1, by 2, parentheses, x minus 2 pi, parentheses, plus 2. Alright, I'm going to erase x for just x. I could just copy and paste this, or type it again, whichever is more convenient for you. And I can start typing in some of the values here. Like I know that's 0. Okay, and we can actually verify. Here I know that they gave me a really weird value for pi over 2, but I know that's an intercept, so I'm going to write that as pi over 2, 0. And when I pressed in pi, which is the next biggest one, I saw that it was undefined. That's going to be where my isotope is. I also typed in 3 pi over 2, which is like halfway between pi and 2 pi. And so that's 4. It's going to go as high as 4. And then 2 pi, I got 2, as you can see here. So you can see where all these values are coming from. And then the last one I did before I kind of stopped was 5 pi over 2. And when I got 3 pi, it was undefined. So notice whenever I have odd number of pi's, it's where my isotopes are. Even number of pi's, I actually get a value. Okay, so let's plot some of these on our part B. Half pi 0. And our isotope is actually going to be going right through pi. So I'm going to draw a vertical line as best I can through pi. Okay. And that's going to be kind of going up and down. For this next one, that would be 3 pi over 2, comma 4. And that'd be 2 pi 2. 5 pi over 2, or 5 pi over 2, 0. So again, my graph kind of goes up and down. And our isotope is right here at 3. Now, I know it's not a perfect sketch, but at least I have a sketch of those points. So stop here just like it says in your worksheet, and let's go ahead and do some of the problems from the packet. And we'll see you back for Explain 2.